Cool. Alrighty, folks, it is 6 o'clock. That means it is spatial visualization time. The best time of the week. No, not really, because it is exam week too, which really makes this suck. So I really want to impress upon you, right? This is the first thing I'm going to say, and I really want you to listen to me because I mean it, right? If you have an exam tonight, if you have an exam, coming up this week, at the end of this week, right? Please go study for it, right? We'll figure out this. We'll figure out spatial vis, right? I know that exam weeks are stressful, especially APPM exams, right? So if you have an exam, please go study for it, right? Don't stress yourself out. If this is a cathartic thing to like draw squares and all that stuff like that, totally get it, right? You're more than welcome to hang out here. We'll get this out of your way. But again, if you are in the middle of scary week with tests, all you need to do is email me, okay? Email me and let me know that you're going to be going and studying this week, and we'll figure you out, okay? So let's get going so that we can get you out of here and off and running to do bigger and better things. First off, I hope that you all have eaten. Maybe you have a snack on your desk, right? I tried to get this workshop scheduled later in the day so that it was kind of after you might have had dinner, right? So please come to this, with some food in your stomach so that you can play around with this and interact with me here, okay? So this is week 2 of Spatial Viz, right? Lesson 2, isometric drawings. Last week we covered orthographic views, right? And if you recall, orthographic views were kind of like a face, a flat-faced version of our, of looking at a part, right? You're looking head-on, straight on to the normal view of a part, right? Whatever you want to call it. That was what we were trying to accomplish. Whereas this week, we're going to be looking at a 3-dimensional view, right? Isometric. So we'll get into that. But first, I wanted to ask, does anybody have any questions? Anything going on that they need answered right now before we get started? No? I'm not very good at watching the chat, just by the way. So I'd much rather you just interrupt me. Please just interrupt me. Don't make me read. I can't do it. No. But yeah, let me know if you have any questions and we'll pause here. But let's chat. First things first, I want you to open up the viewing options from the screen share window. Am I sharing my screen right now? Dang it, right? I did this earlier today. Dang it. Okay, now I'm sharing my screen. Here we go. Good. I want you to open up the viewing options from the screen share window, right? And I want you to just find this annotate tool, and I want you to open it up. Just get it ready, right? So that later on, when we start to, talk about how to do these activities, right? You can just start drawing on my slides, right? Don't be disruptive, but obviously, if you participate, right? That's great. I love it, right? And the best part is it's anonymous, right? So or at least it doesn't post your name on here. On the recording, it actually does, which is interesting. So don't be a jerk. But okay, right. I see. Get it out of your system. No. But keep that in mind, right? I want to invite you all to draw on my slides so that we can make this an interactive kind of fun experience, right? I also really hope that you'll, if you have the opportunity to do so, just turn on your cameras, right? I don't get to see enough of you during the day. So moving on here, I'm going, oh goodness, am I going to regret this? No, I'm not going to regret this. I'm just going to clear this for now. We'll start talking, right? So last time, orthographic views, right? Orthographic views was this kind of projection, right? Where we were looking at one face of a part. If we were looking, if this is our eyeball down here in this corner, right? Where's my laser pointer, right? This is our eyeball right here. Then we were, if we were looking at this face, this side of our shape, right? The orthographic view would look something like this, or kind of like 2 nested L's in here, right? And so today, rather than going from isometric to orthographic, we're going to be doing the opposite, right? We're going to be going from orthographic to an isometric view. But with that in mind, how are we going to go about this? Well, let me take a step back real quick. Orthographic meant, you know, perpendicular, right? Ortho meant normal, graphic means picture. So what does isometric mean? Can somebody help me out there? Just go ahead and unmute yourself, right? Go for it. What does orthographic mean? Or not orthographic, isometric. What does metric mean? Let's start there. That seems like an easy one. Metric. Well, Andrew just exploded, so that's fun. What do you think? Metric. What does metric mean?
Is metric like measuring?
Very good, right? It's a measurement, right? Alexis, thank you very much, right? So it is a measurement, right? So and then what does RIP? I just realized what happened. What does ISO mean? Well, ISO means the same, right? You can think of like in chemistry, we have ISO bars and isometrics. I'm sorry, isotherms, right? The same. These are what is it? Isotopes, right? The same number of protons, I think, right? This ISO means that all measurements are the same. Isometric, the measurements are the same. So this is what this means is it's not really necessarily that it says it's, hey, it's 3D. What this means is that all of the directions that all of the axes that we're looking at, right? Whether they be in, you know, since even though we're looking at them at a perspective mode, these axes are all going to be projected in the same amount in each direction. We'll see how that looks. Anyway, so when we are trying to project this orthographic view, let's say that this is the plus Z orthographic view here, right? When we're trying to create an isometric view of this, what do we need? Well, we need to create a grid, and you'll notice that the grid that we're starting with is not like the grid that we had last time, right? You see how it's kind of zigzagged, right? It kind of moves up and down. This is an orthographic grid. You'll notice that lines like this, right, that go across here. Let me start with a line here. I'll start with the yellow line, right? A line like this, and a line like this, and a line like this might describe a three-dimensional coordinate system, right? It's kind of like looking down you know, axes like this, right? If we had our three coordinate axes, X, Y, and Z, you're kind of looking at them like this, right? So, but if we were to, you know, how would you describe this shape that we're looking at right here, right? Well, we already saw it in 3D. In fact, yes, I've got a little thought bubble, right? As if it's dreaming of becoming 3D, right? This is what we're ultimately aiming for. But in order to go from this orthographic view to this 3D view, what information do we need in addition to this little layout, this little grid that we have, these rectangle and two squares? It's not quite enough information, right? What are we missing? What's that?
The depth.
The depths, thank you very much, right? So we need some sort of indication of how deep these blocks are. You can think of them as columns of bricks stacked on top of each other coming from the screen out towards our faces, right? And so we need, let's see, come on. I see, my mouse. We need depth gauges, right? This is called a coded plan. This is what I'll call it, right? It's called a coded plan. And just by the way, you'll notice that this top rectangle, I ended up splitting it down the middle. Technically, right, when we're drawing an orthographic view, since these two top squares right here are on the same level, they should not have this section, this edge in the middle, right? Last time we learned that in the orthographic views lesson, right? But in coded plans, we actually label each individual square, right? So just keep that in mind as an interesting little difference between how we should draw coded plans and how we draw orthographic views. Okay, so how do we translate this coded plan now, right, over into our coordinate system? Well, let's see, what is my next slide? We need to first establish a reference. This is what we did last time. This is what we'll do every time at the beginning of our lesson, right? And so let me clear my drawings, right, so that I can get my nice slide version of my coordinate axes here. That's great, right? We have our x-axis coming off to the left, the red axis, the y-axis going off to the right, and then the z-axis going straight up. And you can see that my eyeball right here is kind of looking, again, into the maw, into the corner of this coordinate frame, right? So how do we draw this? How do we actually go about drawing this? Well, the thing is that last time drawing orthographic views of isometric shapes was, I'll say it, even if it wasn't easy last time, it was the easy one, right? Compared to this, right? And so that's not necessarily to scare you, but it is kind of an excuse for me to say this. Let's just do one, right, together. Just kind of follow along. I'll ask y'all to, draw on my slides a little bit right here and there, right? But for now, let's just kind of take a look at how this goes, because the process is a little bit backwards from what you might expect, right? So first things first that I suggest we do is we start with the point that is closest to our eyeball, right? So if our eyeball is right here, right, then the point that we're going to start with is right here, right? Very good. So if we were to describe the coordinates of this point, right, again, say in, let's see, that's yellow, red, blue coordinates, right, in that order. What are the coordinates for that green dot if it's at the very bottom of the stack of rectangles, of cubes? What are the coordinates? Let's ask this. What's the z, the blue coordinate, if it's at the very bottom of the stack? What do you want to call it? 0. Okay, great. Fantastic, right? It's the 0 layer, right? That's great. Okay, now x and y, the yellow and red. What are those coordinates?
2 and 2.
2 and 2, right? 2 here and 2, 2 here, right? Very good. So if we were to draw that point on our grid out here, right, we need to go 1, 2 in the yellow, 1, 2 in the red, and then, well, nothing up in the blue, right? So right here, this is our coordinate system, right? This is our first stop, right? Okay, now, starting from this point, I want to go and draw all of the edges that kind of percolate from this point. Spider web that comes away from this point. Andrew is having a lot of trouble. He just keeps exploding. I hope you're well, Andrew. I'm going to let's see. So how do we draw that? Which lines can we draw? In fact, let me do this. I'm going to draw the lines on this coded plan, right? And I want one of you to draw, or some of you, right, to draw the lines as they correspond to our isometric view, right? So this edge and this edge, how do you draw those edges? Somebody do it for me. Hey, look at that. Sweet. We got lines. Look at that. Beautiful lines. Pink is going a little bit crazy, but we got it, right? We get it. Yeah. Perfect. Wonderful, right? And I'll just kind of overlay this. The interesting thing, just by the way, for those of you who are using that thicker drawing tool, it's actually not a thicker one, it's a highlighter. I don't know why they didn't make it a better symbol for it, but it kind of makes this weird ghostly image. So you can thicken your drawing tool in the color, in the format option of the annotation tool, okay? So here's these bottom edges, right, of our coded plan projected into the isometric view. Okay, very good, right? Now, I want to, we're still missing an edge, right? We drew the kind of the XY versions of those edges, right? But there's another edge coming from this vertex. Where is it? Well, it's coming up and out of this corner, right? It's coming towards us because there is a cube that comes out towards the, towards the camera, right? So somebody draw that one for me. I can't really draw that in my coded plan, but describing it with words and noting its location here, where does that edge go? Hey, look at that. Very good. Thank you for the red line. Oops, goodness. Right there, right? So we've got this vertical edge. Sweet. Awesome. Wonderful. I appreciate you all for doing that, right? Along these same lines, the vertical edge that we just drew, right? I'm going to ask you to draw these two, right? These two vertical edges, right? Again, coming out of the board, right? Somebody's drawn the red one, right? Why did you go up to? Or why did they go up to? Somebody describe it, even if you weren't the one that did it. Why did you go up 2 and why did you go up 3?
Because it's labeled as 2 and 3
Very
on
good,
the
right?
Z orthographic view.
Exactly, very good, right? So these cubes and these corners are 2 blocks high and 3 blocks high respectively, right? And so once we've done this, now all we need to do is kind of go back to that first step of going back along the edges of the orthographic view, right? And finishing those edges out, right? So somebody's starting to draw these edges, and you'll notice that this is an interesting point, right? If I were to draw, can I actually, I don't want you all to stop necessarily, but I do want to show you something, right? Is this line correct? If I were to draw this line right here, right, from this corner, right, out here to this edge, right, that would be, let me draw it in a different color, right, from this corner across here, right, would that be correct?
No.
No, I'm seeing kind of this, right? No, that wouldn't be correct, right? Because unlike what we did before, right, across the bottom of this thing, right here, there is a break in the elevation when we get to this point along this, second too high cube, right? And so what we are already kind of getting at with the folks who are starting to draw on my slides, right, is that once we reach this point, we actually have a jog, right? This change in elevation that makes it, well, look like an L shape, right? So this jog right here is designated by this pink line, right? And this blue line, right? At different elevations, right? So again, I don't want to necessarily beat this into the ground, right? But it's hard to see when we're first, looking at, when we're trying to describe the rules of engagement, how do we actually describe what we're doing? It's kind of like, well, sometimes we follow the lines, but then sometimes we actually don't, right? Depending on if it's a higher level or not, right? It's hard to describe it. But I guess if I had to make a rule, right? Anytime that two block columns meet up against each other, right, there's going to be a separation in the vertical distance that of those shapes, right? So let's just keep going with this, right? Again, I told you that we'd just kind of cruise through this one and then we'd have another example where we dig a little bit deeper, right? So somebody drew this yellow line. That's fantastic, right? What else do we have, right? Somebody has drawn this line, right? And why is this green line? I understand where it's coming from, right? And in fact, based on what's back here, right, I might suggest that this is what you were going for, right? A dotted line along that back axis, right? So last time you'll recall that hidden edges behind features that were blocking other features behind them, right? Hidden edges were dotted. But in this instance, when we're doing these isometric views from coded plans, we are not going to do any dotted lines, no hidden edges, right? Things get way too messy in order to do that, right? So I'm actually going to clean this up a little bit, right? I'm going to delete this back edge, right? And now it looks like with the amount of work that everybody's been doing, we are pretty much there, right? So everybody has collaborated so beautifully. I absolutely love it. It's wonderful. We have these edges here. Okay. Here's an edge. Here's an edge. Here's an edge. And here's an edge, right? So again, right, we have these multiple faces, right? Here's this L shape. Here is, let's see, another, oh my goodness, my dog is very excited. Here's this L shape, right? And then we have, I don't know, I could keep going, right? We got a lot of faces, but you get the idea. Here's that L shape, okay? Okay, so let's break this down a little bit, right? Break this down a little bit more into its constituent parts, right? So, oops, sorry. Oh, I see. We're drawing notes, that's fine. So just real quick to kind of give you a little bit more perspective on how this grid works, right? Because it's kind of a mind trick, right? It's kind of a little bit of a play on the eyes, right? You can picture that this grid works as like putting a cube in the corner of this thing, right? It's coming out towards us. And then these yellow and red axes, I made this little animation just to show how it's, you know, the kind of the direction of these three axes, right? So this is what we're looking at, right? And we draw our part, right? Nothing terribly surprising since we saw this over here earlier, right? But if we were to label the heights of these columns, right, on each of these corners, on these blocks, right, it would look something like this. So moving on to another example, let's play around with this. Now, when we start doing this on our own, there are a few, these tips are going to be really important, right? And I want you to internalize these, right? If you need to come back to this slide later, that's fine. Just keep an eye on it, right? This tips section is going to be really important for just kind of remembering the process here, right? First things first, align the paper in landscape mode. If your diamonds are upright rather than on their side, things are not going to work. Things just go topsy-turvy, right? So make sure that your paper is in the right orientation. In fact, the downloadable grid paper that I have on the Canvas site will tell you, you know, hey, align it this way horizontally, right? The next thing, define your origin, viewpoints, and axes, right? This is, right, we've said it before, we're going to say it every single time. The first thing that you do is create a reference, because in order to describe what we're doing, we must have a rigorous coordinate system to describe and compare our, you know, our goings on with, right? So define your origin. I'm just going to, you know, again, right? Who cares what the letters are? Who cares what the colors are? Z, Y, X, I've got orange, green, and blue, or purple. And here is my viewpoint, right? I slow down here because last time, would you agree that if I were to have drawn my grid here, my eyeball was over here, right? Last time we did this example in the last one, right? My eyeball was actually pointing down here, right? But now my eyeball is over here. And so with respect, how about this question? With respect to the way that my eye is looking, right? My viewpoint, right? Like this. Which side of the z-axis are the y and the x coordinate axes going? Left or right? Which side of the z-axis are the x and y coordinates going to be pointing? What do you think? Left. Nice. Nice purple text. Yes. Okay, very good. I'm assuming you don't, I'm assuming a witch took your voice. I don't know. But whatever the reason, right? Yes, exactly. The left side. Right? Because you know, you see that you know, both of them are over here, which is not the same as we had it before, where the X would have been on the left and the Y would have been on the right. Anyway, let's actually just draw it, right? I keep yammering about it. It's going to look like this. Don't let that surprise you, right? This is definitely very different than what we did last time, right? It looks very different. But again, right, all we're doing is we're saying that now our coordinate system, right, if it looked like this before, looks like this now, right? Something like this. Is that right? Or am I backwards? You get the idea, right? Instead of like this, it's off to the side and kind of slanted, right? So how are we going to do this? Well, somebody's already at it, right? I love it. Wonderful. But I want to caution us, right? The suggestion that I have, and I want you to maybe test this suggestion when you're doing this on your own later, right? But the suggestion that I have is start at a corner, at a point that is closest to you. But we're getting a little bit ahead of ourselves. Like, look at the tips, right? I have one thing to say before we move on to that part, right? Assume that all blocks share the same base level. We made this assumption earlier, right? But what I mean by this is that if this is the orange axis, right? The base plate that this is all sitting on top of, right? Don't assume that, 2 is going down underneath and then 3 is up high, right? They all start from the same base level, right? Seems kind of obvious, but just to be rigorous about our definition, let's just say that, okay? Okay, choose a starting point. And my tip is to choose the closest corner. Now, if I was to draw that on here, right, I would probably choose either this corner or this corner, right? So let's pick one. I'm going to, I don't know, which one do you want to pick? Looks like folks are maybe choosing something like this, right? This corner? Sure, sounds good to me, okay? So let's get going on this. Somebody's really going ham with this over here in the red, and this is fantastic. However, it makes for great conversation because there is an error going on right now. So there is an error being drawn. Can anybody describe to me it's a small one, right? Can anybody describe to me what the error is? If I was to draw the columns, the column numbers on top of these things, right? It would be, yes, purple is looking good, right? Okay. we scared them off. I didn't want to scare you off, but I think we're getting the idea, right? There was a cube up here, which is drawn right here, right? That's not what we wanted, right? So we needed to move it a little bit back. But you see, take a break here, Red. Let me do some annotation before you get too far ahead of us, okay? Right? Let's take a look at this, right? There's also a bit of a rotation issue that we're dealing with, right? You see how the purple line right here, that's not where this one, this row of 1 blocks is aligned with, right? The line is aligned, this stack of 1 blocks, right, is aligned with the x-axis, not the purple axis, right? So again, absolutely wonderful. I love that this is anonymous, right? Because I get to see people do stuff, right? This is wonderful. So thank you, Red. Whoever you are wonderful. Let's take a minute. I'm going to erase everything, and let's approach this problem rigorously just off the bat, and then I'll let you get going, okay? So starting at this point, what is this coordinate, right? Somebody describe it to me in orange, purple, green. Go.
I just have like a quick question.
Yeah, what's up?
So if we're looking at it from the positive Z orthographic view, why are the X and Y going to the right?
Like this over here?
Yeah.
Yeah, so that's a good point, right? So we're looking at it, the coded plan is in the Z orthographic view, right? But the view that we are trying to project is this view right here, right? This angle from our eyeball, right? If our eyeball was over here, then our axes would look like this, right? We would have Z going up. We would have X's to the left, right? It would come like this. And then purple is to the right, right? But when we're drawing this other eyeball right here, this other eyeball view, you'll notice that the purple axis goes to the left of the eyeball's view, right? Over here. And the orange axis also goes to the right, to the left of the green Z axis. Does that make sense? So we're kind of, instead of looking at it like this, we're moving around such that we're looking at it from a different side, right?
No, but like in the drawing with the coordinate axis, they're going off to the right and not the left.
I see. Am I, let's see, did I get that wrong? Oh,
It's
you are
like
so
flipped,
right.
right?
Yeah, no, you're
Okay.
right. I was
Okay.
wrong. Yep,
I was
absolutely
just
right.
confused. Sorry.
Yeah,
Yeah.
no, I totally understand why you were confused because I totally got it wrong. Thank you absolutely very much. Right. So let me do a quick hot take on this. Right. I can edit this lickety split. Right. I am going to rotate. Oops, here we go. People are watching me. I'm getting anxious, right? Rotate. Flip horizontally. Very good. There we go. Okay. So now when I go back into my present mode, I obviously did it perfectly the first time, right? This is how it was. I'm going to edit the video so that there was no confusion. No, right? That's thank you absolutely so much, Dongyu. That's fantastic, right? You're totally right. The purple and orange axes are going to the left of the z-axis, right? But they're both going to the left, right? Okay, so somebody had drawn those coordinates, right? Let me redraw this little corner, right? And we are back to this point, right? Choose a starting point. I'm starting from this pink line, right? And what are those coordinates? Oh, well, shoot. I should really review these slides. I guess back when I was making these slides, I had made them to assume that this was the corner that we were interested in. So let's do that now, right? Easy peasy. We can shift, right? We're plastic. We're fluid. What are the coordinates for this this point on the very bottom of our grid, or the stack, I should say? 1, 3, 0. Very good, right? So 1 is in the orange direction. 3 is in the purple direction, and then 0 is in the green direction, right? Very good. And so if we were to place this point, this pink point, onto this grid, right, where would we go? Well, I actually have, again, let's just do it, right? So this point would be 1 in orange, right? And then 1, 2, 3 in the purple, and then none in the Z, right, in the green. So this is where our starting point is, right, from where we're starting. Okay, oops, I erased that blue line, but we'll come back to that in a minute. Actually, that was something that we were probably going to need to erase anyway, and we can talk about that, okay? So let's start drawing. I have this edge, right? And, well, let's start with that, right? How would you describe that line? How long is it and in which direction? Somebody describe that using the coordinate system that I have.
2 into negative y.
Wonderful, right? 2 negative purple, 2 negative y, whichever one you want to call it, right? We're going to follow exactly what this black line was about to draw, right? 2 negative y like this, right? Very good. Okay. So 2 negative y gets drawn there. How about this one? From that remaining corner, we go negative 1 orange, right? Negative 1 x. So that would be in this direction. Perfect. Thank you, black line. Let's keep going, right? This one, that would be from the original pink point, right? That would be positive 1 orange, right there. Thank you, purple. And now, what about this line? Are we going to be able to see that line? If I say we won't be able to see that line, does that make sense, right? You can see that there's going to be 2 and 3 bricks stacked in front of us, and we won't be able to see the back edge of this block, right? So we're not going to draw that line, right? So now that we've kind of hit a dead end, let's start building up, right? So I want to build this corner. Actually, we did have one more edge, right? This one. So this negative 1y would have been right here, right? Okay. So now let's start building these corners, right? I've got this corner in dark green. Somebody draw it in dark green. I've got this corner in bright red. Somebody draw it in bright red. Got this corner in yellow. Blue. Somebody do it. Pick up your pens and start drawing. I'm running out of colors. How about, I don't know, cyan. Okay. So let's start drawing. Somebody's already put a little blue dot, so we got that, right? So that's good. Looks like folks are starting to draw these things. I'm going to overwrite them in bright green, right, just to make everything consistent once we're all drawn up here, right? But yes, okay. So the blue line, the vertical blue line, right? We draw it blue because it is, we draw it up 3 in the z direction, right? Because it is up against this 3 tall column, right? So here is this edge. Similarly, the cyan corner, which is going to be right here, right? It's going to be going up 3. Right? We can top this one out by drawing this top face of this cube at 3 blocks high, right up at the top here. Somebody's drawn that. Fantastic. Right? And now let's see. This yellow corner, right? That is at the intersection between 2 and 1, right? So this edge is going to go here's up to 1, and we can then build that out here, right? If I drew, let's see, I'm going to draw this pink color is nice and bright, right? If I'm over here and I draw this line up, right, along this edge, then I can draw this line back here, which comes out here, right? And then I can go up again in this corner by drawing it up like this, right? So let me use my green marker for that. So I've gone up, over, and then up and up. Okay, so that's good. And then let's see. I want to ask all of you, right? Currently, there are actually, this is fantastic, right? This drawing looks fantastic. There is one extra line that we don't need. Can anybody identify it? Either like draw a bright pink X on it, or actually there's a stamp. Let's use that. There's a stamp function in the annotation tool. Pick a star or an X or a, there you go. Yeah, wonderful. Look at all that, right? That, oh God, okay, everybody stop, right? That line shouldn't be there, right? And that's because it is all, that entire kind of row of bricks is all stacked on top, is all kind of sharing the same the same elevation, right? So we erased that line, that's fantastic, right? We're gonna keep coming out here. Somebody's checking out those stars, right? I'm gonna draw these edges out here, which are for the dark green and the bright red corners. Those were back there. And then we can kind of take this step-by-step approach down from level 2, right? Go down level 2, and then we build this out like this, right? So it's not exactly easy to see, right? It's still, since we're not shaded, right? It's kind of a hard thing. I'll show you actually a rendered version of this, right? Just so it's a little bit easier, right? But what we're seeing right here, let me ask you something real quick about this, right? These 2 blocks, we can't see them at all, right? Those are hidden completely behind these, the level 2, right? It would be, the first one would be kind of right here. We get to see half of it, right? And then the second one is completely hidden behind this, this one we can't see at all. This one we can kind of only see, let's see, we can see about this much of it, right? So keep that in mind, right? There are going to be times when the features like this get completely hidden behind other features, right? But again, this rigorous definition of starting at a coordinate system, right? At a point and defining its starting, its starting coordinates, and then using directions like +3 in the purple direction, -2 in the orange direction, right? Those are going to be the things that save us from trying to understand exactly where things are going, right? And the reason why I ask you to start at a corner that is closest to our viewpoint, right? Like this, for instance, right? Out here with the stars, all of the stars, right? This corner, the reason why we chose that is because, for instance, right? If we had chosen to start drawing at the origin, right? You wouldn't be able to see most of the lines that you would start drawing off of that corner, right? You wouldn't be able to see, for instance, like this edge. You would see this edge, yes, but as we started to draw this back edge, we would have to go back and erase it anyway, right? So we're kind of saving ourselves the headache of trying to figure out, okay, I've drawn all these lines, which ones do I need to erase now, right? Which ones stay, right? The strategy of starting at the closest point and then working up and back, right, is what I've found to be the most clean way of doing it, right? Digitally, if you're doing it digitally, it's actually not so bad. If you're using a piece of paper and pencil, right, smudges galore, right? If you're using a pen, forget about it, right? So I'm going to clear my annotations. Let's do just a real quick review, right? This coordinate axis, this starting point is at 1, 3, 0. We map it over here. We can start outlining the Z0 layer and then work up, right? So we map out this red line that corresponds to this, right? And then only draw lines where there are edges, no dots, right? So no dotted lines, right? But effectively, we didn't finish this out, obviously, in this example, but we would build up and then start building the edges out from there, right? Again, I don't know, just driving the point home. I know you've seen this already, right? We already did it, but going up 3 here, up 3 here, right? Because that's these two corners. Up 1 here, right? In this corner, going across to draw this, going up again to continue up to level 2, which then kind of builds off from here, right? This and this, okay? Build it out, and we have our part. Does anybody have any questions about why things look the way they do? Okay, 3, 2, half a 1, 1, right? And then there's another one back there. Okay, let's keep going. Oops. So this is one more example, one more demonstration of this kind of starting from the front trick, right? This is the same diagram that you'll see in your in the homework assignment, in the exercise worksheet, right? So just showing you where I'm getting with this, right? Start with the closest point to the vantage point, right? We start here on the lowest level, right? The 0Z level, the 0 yellow level. We're going to work up and out, right? Kind of working along these lines up to, right? In the positive Z axis, out a couple, keep working out and building out those faces out and around, right? The tops of each one of these. And then we finish those faces and cap them off with the tops, right? This one looks weird, right? And I put the tops on there with the numbers on there because, yes, this is a very confusing thing to look at, right? I have a little rendering of what this looks like in 3 dimensions, right? And you'll see that, it's easy to see how this thing is built when it's rotating, but the second it moves into that isometric view, it's a little bit hard to see, right? So don't let your eyes play tricks on you. This isometric drawings are used in the real world when we're actually trying to present, well, orthographic drawings are used in machine shop drawings, right? When you take a piece of equipment down to be manufactured in the manufacturing center, say, on a CNC or a mill, right? Isometric views are typically accompanying those so that we can see a 3D representation of how all of those orthographic views fit together, right? So, practical applications for these things, right, for this drawing, aside from the fact that this is, the spatial visualization and the test that we're building up to, again, is going to be dealing with these isometric drawings of 3D shapes, right? So double incentive, okay? So I have a few group practice problems, right? I'm happy to do this one together, right? And in fact, I'll just kind of sit back and let you all start doing it, right? But we are at the end of our 6:45 time frame, right? So keep an eye out, right? I actually already posted the assignment on Monday, right? When we did our Monday lecture of this course, right? They already saw this stuff, and so they have, you all have the assignment available to you. This recording went a lot more smoothly, right? Surprising everybody, than the last one. And so I'm actually going to post this recording up on the website so you can refer back to it anytime you want to. But yeah, again, if you aren't familiar with what I am expecting of you, right, for the assignment, what I expect is it's very free form. I understand that, right? But the way that this works is I want you to spend an hour practicing isometric drawings. I have a huge array of different exercises for you to pick from. If you do one of them for an hour, sure. If you do, all 6 of them over, 10 minutes each, sure, right? That's fine too. I want you to spend an hour drawing these, take some pictures or some screenshots of the things that you accomplish, and just post those to the Canvas assignment. That will be your work submitted, right? That's all I ask for, right? So I realize, again, this is scary week, right? Exam week. Don't let this get in the way of your APPM exam, right? If anything, hopefully drawing stuff like this is maybe more of a cathartic experience, right? It's a totally different part of your brain that we're using, right? But yeah, that's what I asked. Did anybody have any questions on what is expected of you from me?
I have a quick question to ask
Yeah.
you. So for homework 1, how do you turn that in through Canvas? Do you just turn in the workbook, workout, or all?
Yeah, so for across the board for all of the assignments in this entire workshop series, right? Each week, all I want is a set of pictures, like whether they be from your camera phone or if they're screenshots, if you were doing them on your computer, right? If you were doing them digitally, right? I just want some evidence that you have put in some work, right? The idea that these are the correct answers, right? If it's just a big sheet that says A, B, C because the workshop or the exercise that you did was a multiple choice worksheet, that's fine, right? I just need to see that you've tried something, right? And I can go back, the more explicit that you are with, hey, this is the problem in the workbook that I was doing. This is the answer that I got, right? Then I can give you some feedback. I can say, oh yeah, good job, right? Or I can say, well, actually, maybe this is the one that you're, maybe you might have gotten confused back here, right? The more information that you give me, the better. But this is the way that I am putting a ruler up to the participation scale, right? It's more than just showing up here. It's just showing me that you've actually put in a little bit of work to practice this thing, right? Because this is completely for you all, right? This is for you. At the end of next week, after we practice 1D and 2D rotations, I'm going to give you access to do the test again, right? By being here, you have earned eligibility for trying that test again, right? So you can get that 5% credit on your grade back if you try the test again and you get over 20%. But just by being here at all, right? Maybe some of you scored higher than 20% or 20 out of 30 on the test. That's great. If you are, you're welcome here because everybody is also eligible for 3% extra credit on their grade as well, right? So I want to reward you for putting in the time and the effort to learn a new skill. This skill is incredibly important. I can't tell you how many times I've gone and chatted with people in industry and I say, hey, I teach this class called Spatial Viz. And they're like, boy, I sure wish, my colleagues knew how to do Spatial Viz, right? I'm not kidding, right? I hear it all the time. So this time, the small amount of time that we're going to give into this workshop is going to pay off. And, you're hopefully, I'm more than happy to give you some extra credit for it and give you some opportunities to earn that grade on the actual test, okay? Coolio? All right. You all know where to find me if you need me, right? mo.woods@colorado.edu. That's my email address, mo.woods. And you can get me on Canvas, right? And I think that'll do it. Oh, one last thing. Let's see. I'll bring that back there in just a minute, right? Thank you for drawing that eyeball. That's perfect, right? You have attended lecture. Please complete the assignment. I will be posting these things and the assignment, right? This is actually something that I forgot to mention last time, so let me show this real quick, right? I'm not going to be berating you with announcements on Canvas anymore, right? Unless I will be posting announcements, but it's to the the SV workshop group. In Canvas, you can be part of student groups, right? I just discovered this, right? So I'm going to be posting to that group specifically just reminders. If you want those reminders, that's great. Sign up for that group and you'll hear from me. If not, then I'm assuming that you know what is expected of you, okay? So, because I know that I've sent you a lot of emails and stuff. I continue to berate you with it, and I apologize, but I want to be very clear, right? Spatial Viz is kind of a confusing thing for some folks. So looks like we have some folks chatting. Left. Oh, that was from something else. Okay. Very good. Okay. Does anybody want me to stay here with this exercise for a little bit? Let me get to this.
Mo, I have a really quick question before we move on. I was wondering where we could check our attendance for this. Like,
okay. Yeah. So if you have submitted assignment 1, you have attended class, right? I don't really have the, it's an honor system thing, right? Unfortunately, oftentimes there's probably going to be I think there's 70 people who are, technically I would expect to see in this workshop, right? I don't have the capacity to manage all of that, right? So I'm trusting you all that you're attending this workshop. If you don't need the workshop, that's fine. But I still expect an hour's worth of practice for you. So if you're just kind of bumbling through the exercises aimlessly, you may as well show up to the workshop, right? You may as well watch the video, right? So attendance is your assignment having been turned in, right? That's what I'm counting it as. And so I can see in there, I'm going to try and grade some of them, right? Just kind of go quick and say, hey, you turned something in, you get credit, right? But if I see like 2 lines drawn on a piece of paper as an assignment turned in, like, sorry, no, that's not what this means, right? I want you to show me some evidence that you're working on it, right? So good question though, Alexis. I appreciate that. Cool. All righty. Well, it looks like somebody's drawn some cubes. That's fantastic. Thank you so much. Say hi to Felipe. I will. How does Kalisa? How does she know my dog's name? Anyway, thank you. I will tell Felipe hello. Actually, I'm surprised. I wonder where he is. He's probably zonked out. So anyway, thank you all very much.
Thank you.
Yeah, of course. We'll see you all around. Again, I'll stay here if you want to keep drawing or ask any questions, but yeah. See ya.
thank you.
Yeah, thanks.
See you next week.
Bye. One. Nice. Okay, very good. Yeah. Dog. Shalom, I can't quite tell if you're... Oh, okay, you moved. I thought you may have put your avatar up as you pensively looking. That was funny. You weren't moving. Is he okay? No, that's great. Are Maddie, Maddox, Shalom, Nicholas, are any of you wanting to stick around here on the call with the drawing, or can I hang up with y'all?
Well, whatever.
Okay, cool. Appreciate you. You can find all of these slides on the slide deck on Canvas, right? So for now, I'm just going to clear this out, and we'll see y'all later, okay?
Have a good night.
Thanks, you too.